Okay, a few people have asked about the final homework questions. So the last parts were where we were given functions. For instance, here's one: y equals 5x squared minus 45 over 3x squared minus 12. And we were asked to compute some things about these and then match with some of the graphs on the following page. And I just wanted to do one as an example. So the first thing we're going to look at is, well, let's maybe look at the y-intercept. So y-intercept, well, this is where our graph hits the y-axis. And if you think about what's going on with the graph, well, the y-intercept, let's suppose maybe it's here. Well, wherever it is, it's going to be where our graph goes when x is equal to 0. So it lies over the point x equals 0, and we have to figure out the y value. So if we want to find this out, we can just plug in 0. Right? And so if we do that in this example, we will see that we get 5 times 0 over minus 45 over 3 times 0 minus 12. So that's 45 over 12, which is, if we can simplify, I guess we can divide by 3, so we get 15 over 4. So this is somewhere between 3 and 4. So if I mark this off, our y-intercept is going to be up here. The next thing is these were called the roots. And I want to emphasize that this is just another word for zeros, or x-intercepts. So the roots of an equation are like, if you think of the roots of a tree, maybe I'll just draw an example. If our function looks something like this, it would be rooted at these points here where it crossed, right? So that's what the roots are. They're those points where the y value is 0. And so to do this, we're going to be setting the function equal to 0. So let's see what happens when we do that. So if we set 5x squared minus 45 over 3x squared minus 12 equals 0, then we can multiply both sides by the denominator. So we could clear denominators, and then we'll get 5x squared minus 45 equals 0. Because of course, if we multiply both sides by the denominator, the right-hand side stays 0. We can divide by 5. So then we get x squared minus 9 equals 0. And this has two solutions, x equals 3 and x equals minus 3. So we can go ahead and fill in those roots on our picture. And the other questions that the problem asked about were about the asymptotic behavior of our function, right? And so let's go ahead and make a new page. So we had vertical asymptotes and horizontal asymptotes. And basically, horizontal asymptote, that's going to be when the denominator, when the denominator is 0, when the denominator is 0, and horizontal asymptotes are going to be related to computing the limit as we go to infinity of our function. So let's go back and see when our denominator is 0. Well, if our denominator is 3x squared minus 12, so it's going to be 3x squared minus 12 equals 0. So we'll go and we'll solve that. We'll get x squared equals 4, x equals plus or minus 2. So that's going to mean that we've got asymptotes here, minus 2 and 2. And horizontal asymptotes, we want to take the limit as we go to infinity of our function. Well, let's look at it. It's 5x squared minus 45 all over 3x squared minus 12. And if we take that limit, it's just going to be the limit of the leading coefficients. That's going to be 5/3. We can just see that based on the intuition that we've built in the class. And so the asymptote is going to be the line y equals 5/3. And so if we draw that in, that's going to be between 1 and 2. It should sort of be here. Right? And now we just have to sort of try and connect these features with the graphs on the next page. So really we could just look at all of them and see which ones had this property, and we'd see that there was only one choice. But we can actually piece in a lot of the picture of the graph ourselves. For instance, imagine you started here. Let me do it in a different color. Imagine you started here at this green point on the right. Well, we know as we go to the right, we basically have to approach this asymptote. So, I mean, at a first guess, it may look something like that. And if we come down, well, we have to approach this asymptote. And now you may say, well, what's the graph going to look like on the left? Well, on the left, it probably has to look exactly the same. So that's a pretty good guess. And now in the middle, well, when we move to this middle region here, there are a couple choices. So let's sort of look where I'm drawing my stars. So our graph could either, one option would be it could come up from the bottom, it could come up this way. And another option is that it could come down from this asymptote that way. Now, it's maybe a good point to pause the video and try to think which one is correct. And so, if you've paused the video and come back, well, we have to match this point up here, this y-intercept. And so if we came from down here, that would mean we'd have to kind of come up this way. But that would mean we cross the x-axis. And we're only allowed to cross the x-axis at our two zeros, at our two roots of 3 and minus 3. So we're not going to be able to do that. So it must mean that we sort of come up here and we go like that. So this is a graph sketching process. It does have a lot of steps, but basically each thing is either plugging in x equals 0 or setting the function equal to 0, or looking for where the denominator is undefined, or looking at the limit at infinity. So thanks for watching, and I'll see you soon.